Right. Hi, everyone. So I'm Anna, I'm a neuroscience major, and I believe that empathy is our most powerful tool in our fight against addiction. I don't think it's just about understanding someone's struggles, but truly stepping into their shoes, feeling the weight of their challenges, and acknowledging that journey. So throughout my time here at Regis, I've explored this topic of addiction quite a bit. But I've also learned quite a few things from my interactions and experiences within the neuroscience department, and those are two things. So the first being that knowledge is key. I believe that knowledge is key that allows us to bridge the gap and truly connect with others, specifically during those times where we really can't relate with them. The second being that I'm about to spew a lot of information at you, and I know that can take some time to digest, and I encourage you all to digest that at your own pace. What I acknowledge from that is that you may have some differing opinions at the end of that versus like what I'm actually projecting today, and that's okay. So like I mentioned, neuroscience major, learned a lot of really cool things throughout my 4 years here at Regis in the neuro realm and biochem realm. And I guess like there's just such a big reason that addiction is just an important topic for me, and it's because it hits really close to home. So I grew up in a Filipino household, not really knowing my biological mother. And I didn't really start asking questions about her until I got older because I noticed I didn't quite look like everybody else. And when I did start asking questions about her, I kind of noticed that everyone was pretty aloof, and the little bit of description that they would give about her were kind of negative. And I put the pieces together and came to the conclusion that my biological mom's probably not someone I want to know. However, to my surprise and confusion at the age of 11, someone was handing me the phone saying, "Hey, talk to your mom." And like I said, this is super confusing because of all the negative descriptions I was getting about her throughout the years. I never thought I would be exposed to her, have the opportunity to get to know her or talk to her. And so after the shock value kind of wore off, I said hello, had some random conversations I don't really remember. But what I do remember is asking her pretty bluntly, and please remember I was only 11. I said, "Why are you a person?" And there was some really awkward silence that fell throughout the room that I was in with my family and over the phone. And I was so sure that I was going to get in trouble. But she answered and she said, "Every day I try my best to be a better person. I'm just so sorry I couldn't have been a better mother." And so this confusion started off at the beginning, and it's just a theme throughout this whole thing. And this wasn't my first experience with her either. So shortly after this phone call, I ended up living with her actually during my freshman year of high school. And no, I had never met her at this point. It was kind of just on a flight there. I only knew who she was because there was a sign that said my name on it, and kind of went home with her. I was confused because of all the negative descriptions I got about her. She wasn't that woman. She was super kind, super lighthearted, and she was honestly a really great mother to me. Unfortunately, towards the end of my freshman year, she had a lot of drastic personality changes that were negatively impacting me. And unbeknownst to me, she had relapse. Now, I think it's really important to mention at this point that growing up, of all the negative descriptions I've got of her, no one actually told me that she had a substance use disorder. She was honest with me within the first initial weeks of me living with her about her drug use in the past and the negative consequences that came from it. But needless to say, at the age of like 13, 14, I didn't know what it looked like for someone to be high. I didn't know to attribute these drastic personality changes to like a something bad's going on here kind of thing. And even more unfortunately, shortly after these behavioral changes, she disappeared. And when I say disappeared, I mean, she didn't come home, didn't know what was going on. And shortly after that, I was on a flight home to my family trying to grapple what just happened. And so I think there's a few more things that I would like to share with you about my biological mother. So my biological mother, her addiction started when she was 14 years old. And she became pregnant with me at 15, had me at 16. And 2 years later, she was pregnant with my half-sister. Shortly after that, she relapsed and went to prison for the first time. Now, after this, she came out of prison had another daughter, left that daughter with a random friend, relapsed, went back to prison. Came out of prison, relapsed, went back to prison. Now, this last time that she came out of prison, it seemed that she had gotten things together. She had found the path that she needed to be on, had another family, another daughter. And this is the point where I came to live with her. And we all know how that ended. So knowing all of this, it was really hard for me to have empathy on the situation and kind of understand how someone who should know that there is a cycle that they're in and is putting their family in, why they would continue that. And so I had a lot of just a lot of resentful feelings towards not just only her, but people who struggled with addiction in general. And so I'm here though, my talk is empathy for addiction. And the reason why is because this isn't just my story. We are in an opioid epidemic, and we have been for quite some time. There's a few things that I want to note about this graph. And I mean, not going to just point stuff out, but the age demographic is as young as 12 years old. And that is 2 years younger than my biological mother when she first fell under addiction. The second thing here is that these are just drug-involved overdose deaths. And as unfortunate as that is, this does not account for, and we cannot account for, all the people who do have a substance use disorder, drug addiction. The third thing is that given the story of my mom and the title of this talk, I bet you all thought, oh, this is going to be about drugs, and maybe that's not really relatable to you and you don't have those experiences. But all forms of addiction affect the brain pretty similarly. All forms of addiction have comorbidities, and I want to go over some of that. So I created this graph from data that I got from the NIH. And I'm pretty sure that there are one or two of these subcategories that we probably think, I could probably spend less time doing that, or maybe you even struggle with. I'm not a psychologist, so I can't quite diagnose you all with a behavioral addiction, but that prevalence to us having those struggles really speaks volumes. And I, along with a lot of researchers, would agree that some behavioral addictions are far more prevalent than that of drug addiction. But why is that? These things are marketed to us. They're so easily accessible, yet they still affect us negatively. They affect our work ethic. They get in the way of relationships. And like I mentioned before, they impact the brain pretty similar to that of a drug addiction. So I want to go over the why this happens. Starting off with dopamine. So dopamine is a neurotransmitter I'm sure we have all heard of. However, there's a lot of major misconceptions going on about dopamine. Throughout my years here, I've heard dopamine to be a pleasure chemical, and that is simply not the case. There is a reason it is classified as a reward chemical and not a pleasure chemical. And I love a good visual aid, so I'm gonna walk us through what this neurotransmitter actually does and how researchers prove that this is a reward chemical and not a pleasure chemical. So we have our favorite thing that we like to do in neuro is use rats to prove our hypotheses. And so we take a rodent, we expose them to two different areas, one that secretes water, one that secretes sucrose. And what the rat will do is they're like, oh, I really like sucrose. I'm gonna go back into that box. Great. So to prove that dopamine is not in like a pleasure chemical saying, oh, it's because the sucrose is there, they really liked it, now we have the surge of dopamine, they went and they removed those dopamine producing cells within the rat. What they found was this rat's like, I know sucrose is good, but I don't really care to go out of my way to get it. So what it does, So what they did next is that they directly gave these rodents dope sugar. And what they found is that it still enjoyed it, but like I mentioned before, it totally removes that motivation for them to go seek it out themselves. So essentially, you can look at dopamine as something like you went and you had a donut for the first time, and your body's like, that was really good, but dopamine's like, oh, you should really go get another donut, and not the other way around, where we're like, we had a donut, it's releasing dopamine, it's because it's pleasurable, it's motivation. These are who are really responsible, and that's our endorphins, stuff like oxytocin for love, and opioids, like our endogenous opioids. And so taking what we now know about dopamine to truly be, how can we apply it to addiction? So we have the ventral tegmental area, and this is a pathway that projects to the nucleus accumbens, which is known to be our main function of reward. The prefrontal cortex, pardon me, which is known for executive function. The amygdala, which is for emotional regulation and fear, and the basal ganglia for voluntary movements and habit formation. So normally, the VTA sends dopamine off to all these areas, and cumulatively, they're known as the mesolimbic pathway or the reward pathway. So again, I like a good visual aid. So what's happening on a normal condition, the way we can look at it is like this. So we're hiking on a hot Colorado summer day. We need some relief. We see a stream. We go through said stream, and it's just enough to keep us going on our hike. However, under addiction, that stream's suddenly a wave, and it's too much. Now we're soaked. We're going to get muddy if we continue this hike. We just want to go home. There's this surge of dopamine that happens that has all these negative domino effects within the brain. And while all those things differ based off of behavioral or substance, this is a pretty general TED Talk, so we'll just keep it at that. So to kind of recap, we have a surge of dopamine, whether it's an abnormal influx from things like drugs like meth or heroin, or rapid fire stimulation for behavioral addictions. And these are the negative side effects that we get, whether that is the killing off of these dopamine producing cells, a reduction in the dopamine receptors, or atrophy within the brain. So all of those things lead to this cycle of addiction. I know I mentioned the nucleus accumbens earlier, but we're really just going to be focusing on the basal ganglia, the extended amygdala, and the prefrontal cortex. And so what I want to do is kind of walk us through these stages, but more importantly, I just want to notate that how they function under normal conditions versus under addiction. So our first stage is the binge and intoxication stage, and we're starting off with the basal ganglia. So the basal ganglia is, like I mentioned before, it's not just about voluntary movement, it's about habit formation. So I created this cute little habit loop. Hope you all enjoy it. And we're going to talk about how this changes. So if you're stressed out and your friends invite you to go meditate or do some yoga and you find peace after that, the next time you're stressed out, you're like, maybe I'll try that again. You find that reward. And so the cycle ensues. However, when we introduce drugs or behavioral addiction into the system, we're going to find that this doesn't work anymore. Yoga, meditation, what once made us happy isn't going to quite cut it for us anymore. And what we have to do now is supplement those things that did bring us that reward. And what's really upsetting here is that things like a drug addiction or more behavioral, you're going to have to start doing more and more and more of to get that same reward. So whether that's increasing the dosage or spending more time scrolling TikTok, etc. So the next stage of this involves the extended amygdala, which, like I mentioned, is purely emotional regulation and fear. There's other complex things that are going, but for the sake of this is what we'll go with. Now, under addiction, we have the amplification of negative emotions, and we experience those physical symptoms. And a lot of those mechanisms are a bit complex, but I'll tell you what. I'll simplify that a little bit. So what essentially happens here is that we have deactivation of the reward pathway, which is contributing to those negative emotions that we're feeling. And that dysregulation causes an increase in stress hormones, kind of triggering that fight or flight within us. And within this graphic, what we have is a PET scan. And so basically, to break this down for you guys, we want to see red. Red indicates blood flow. And this is within the extended amygdala. And what they're noticing is that there is less activation within the extended amygdala for someone who has been under the influence of cocaine for quite some time. So last but not least, we have the prefrontal cortex. And like I mentioned before, this is known for its executive functions. So stuff like decision-making, impulse control, and judgment. And basically, under addiction, all these things are flip-flopped. So I want to talk about this graphic really fast because I mentioned that there can be atrophy within the brain, and this is essentially what's happening here. This is someone who has alcoholism, and in the scan, the light colors notate that there is a deficit in gray matter volume, so atrophy. And so, like I said, that these things flip-flop. So now we have impaired decision-making, we're more impulsive, and we have this lack of judgment. These all contribute to this preoccupation anticipation. A way to look at it is basically thinking like within that period of abstinence, now all you're thinking about is the next time you can get high, the next time that you can open your phone and scroll on social media. And it doesn't matter if you have some TED Talk to practice on or an appointment to be at or whatever your job is, that is your primary focus, and you'll do, nothing's going to stop you to get it done. So like the theme of this, I love a good visual aid. And instead of talking about what's happening, I love looking at the facts and just like, I like proof from visual aids. So on the left-hand side, we have a normal brain. And on the right-hand side, this is a brain that has experienced chronic use of heroin. And so these are SPECT scans. They're 3D visualizations of blood flow activity within the brain. And I just want to notate that with heroin and meth, they act on our mu opioid receptors, which are everywhere in the brain. And so, like I said, when your brain is under addiction, to kind of compensate, it'll kill off those dopamine receptors, some neurons, and that, of course, will reduce blood flow to that area and can cause that atrophy that we can see here. This next image I want to show you is a PET scan. And like I mentioned before, this also indicates, this also indicates blood flow. And the most important thing here is I just want you guys to see how similar this cocaine brain is compared to the obese brain scan. And this is again the extended amygdala, and just how similarly that a behavioral addiction and a drug addiction can affect the brain, like I mentioned. So some quick facts that I wish I had more time to spend on. But prior to this addiction, what leads people to it? So what I found really crazy is that genetics can account for 40 to 60% of someone's susceptibility to addiction. And so that was obviously a really important fact for me because of my biological mom. Another thing is just the environmental factors that attribute to this, just things like peer pressure, traumas, accessibility, inequalities that people experience. For my biological mother, it was everywhere around her when she was growing up, and there was a lot of peer pressure. And I think as a 14-year-old, she ended up making a very uninformed decision on the substance that she was going to ingest. Another thing is that social stigmas really exacerbate this problem, and we don't see the help and treatment that truly deserves to be prioritized within this realm. And I'll go a little bit over that in a second. So during our neuroscience seminar, we had Dr. Goen come in, and we're talking about addiction right now. So we kind of helped out with this TED Talk. But he told us that addiction truly isn't a moral failing, but a chronic relapsing brain disease. And to fall back on that quick fact of, I think that social stigmas really play a part in, and discrimination really play a part in kind of pushing addiction into this, like, we don't treat them, it's a choice, like these others, these outcasts. I think if we actually look at addiction as a brain disease, then it would get the treatment that it deserves and the prioritization that it deserves. So just some final thoughts for you all. My opinion after learning all of these things and a little bit more that I wasn't able to cover with you all today is that I don't believe that addiction is a choice. I think there's a lot of times that informed decisions are made and we get stuck in this vicious cycle where we stray back to based off of the way it alters our brains and the chemistry within them. Another thing, like I mentioned in the last slide, is that removing the stigma, raising awareness for this, having that empathy will really allow us to treat those struggling with addiction. And like I said, I wasn't able to tell you everything there was, so I encourage you, if this is interesting, to go out and do further research, because addiction is super complex and we learn something new every day. And there's a ton of labs currently looking into all the different mechanisms. So yeah, thank you. Thank you. The